Oh no, someone brought a match to Jupiter. And that's a terrible idea. Because Jupiter is mostly hydrogen. You know, the stuff that burns. So if you struck one tiny match inside Jupiter's atmosphere, what would actually happen? Would the hydrogen catch fire? Would the flames spread across the entire planet? Would Jupiter explode? Or could this tiny little match somehow create a second sun? Well, there's only one way to find out. Let's light the match. And nothing. The flame flickers. It gets smaller, smaller, and then it's gone. No giant fireball, no massive explosion, no second sun. Jupiter doesn't even seem impressed. Because we forgot something very important. Hydrogen may be fuel, but fuel alone isn't enough. Because we forgot something important. Hydrogen is fuel, but fuel alone isn't enough. Fire also needs an oxidizer. On Earth, that's easy. Our atmosphere is packed with oxygen, so ordinary flames keep burning. But Jupiter? Almost no usable oxygen, which means our tiny match never really had a chance. So congratulations, you traveled hundreds of millions of kilometers, carried a match all the way to the largest planet in the solar system, and forgot how fire works. Fine, let's cheat. Instead of relying on Jupiter's atmosphere, we'll bring our own oxygen. We'll build a special ignition device, light it again, and this time, it just might work. Perfect. Now we finally have everything we need. Hydrogen, oxygen, and one tiny spark. So let's try this again. The ignition probe releases its oxygen. The gases begin to mix. 3, 2, 1. Ignition. This time, it works. A brilliant fireball erupts around the probe. For a few incredible seconds, hydrogen and oxygen react exactly the way chemistry says they should. The flames spread through the surrounding cloud. Energy pours outward. It almost looks like we've done it. Like Jupiter is finally beginning to burn. This is the moment we've been waiting for. The chain reaction has started. Right? No. Because we've just discovered a much bigger problem. Not chemistry. Not oxygen. Scale. That spectacular fireball? Compared to Jupiter, it isn't even a spark. It's less like setting a planet on fire, and more like lighting a single grain of sand on an entire beach. Jupiter isn't a giant gas tank. It's an entire planet, more than 11 times wider than Earth. And that changes everything. Our oxygen supply? Gone, within seconds. So bring more. One spacecraft. 1,000. 1,000,000. It barely makes a difference. Fine. Let's go even bigger. Harvest oxygen from icy moons. Mine it from asteroids. Take it from anywhere we can. Pour all of it into Jupiter's atmosphere, and try again. It still wouldn't be enough. Because burning even a tiny fraction of Jupiter would require an unimaginable amount of oxygen, mixed throughout an atmosphere thousands of kilometers deep. At this point, you're not trying to light Jupiter. You're trying to rebuild it. So maybe, fire was never going to solve this problem. Maybe, it's time to stop thinking like chemists. So, chemistry has failed. The match didn't work. Bringing oxygen didn't work. Maybe it's time to stop thinking about fire, and start thinking about force. Forget the match. Forget the oxygen. Let's hit Jupiter with something. An asteroid? Not nearly enough. A giant comet? Now we're talking. Send it hurtling toward Jupiter at tens of kilometers per second. Its immense gravity will pull it in even faster, until it slams deep into the atmosphere. The impact would unleash an astonishing amount of energy. A blinding flash. Towering shockwaves. A massive fireball rising above the clouds. If anything could ignite Jupiter, surely a collision like that could. But here's the amazing part. We don't have to guess what would happen. Because nature already performed this experiment, and astronomers watched the whole thing unfold. What happened next changed the way we think about Jupiter forever. In 1994, nature decided to answer our question. Comet Shoemaker-Levy 9 drifted a little too close to Jupiter. Instead of swallowing it whole, Jupiter's immense gravity ripped the comet apart, stretching it into a long chain of gigantic fragments. Some were more than a kilometer across. Then, one by one, they began to fall. Each fragment slammed into Jupiter at incredible speed. Brilliant fireballs erupted high above the cloud tops. Towering plumes blasted thousands of kilometers into space. Dark scars spread across the atmosphere, some so enormous, they rivaled the size of Earth. If brute force could ever ignite Jupiter, this should have been the moment. The impacts released more energy than humanity has ever produced. The entire planet seemed to shake beneath the explosions. And then, nothing. No runaway fire, no planet-sized explosion, no second sun. The fireballs faded, the scars slowly disappeared, and Jupiter just kept spinning, as if the largest collision in modern astronomical history had barely bothered it. So, the match failed. Bringing oxygen failed, and even the most violent collision nature could throw at Jupiter failed. Jupiter didn't catch fire, it didn't explode, it didn't become a star. It simply kept turning, exactly as it has for billions of years. At this point, it almost feels impossible. How can a world made mostly of hydrogen refuse to burn? But maybe that's because we've been asking the wrong question. We've been thinking about chemistry. We've been thinking about fire. Maybe we should be thinking about something completely different. Because there is another enormous object in our solar system, made mostly of hydrogen, that releases more energy every second than humanity could produce in millions of years. The sun. But the sun isn't burning like a campfire. It's powered by something far more powerful. Fusion. So maybe the real question was never, can we set Jupiter on fire? Maybe the real question is, can we turn Jupiter into a star? Here's the strange part. The sun isn't burning like a giant campfire. Deep inside its core, gravity creates such enormous pressure and temperature that hydrogen nuclei fuse together, releasing incredible amounts of energy. That's what makes a star shine. So why not do the same thing to Jupiter? Because there's one tiny problem. Jupiter is enormous for a planet, but for a star, it's simply too small. It doesn't have enough mass to sustain hydrogen fusion, which means Jupiter is never becoming a second sun. So, the match failed. Bringing our own oxygen failed. A giant comet failed. Even nature's most violent collision failed. Every experiment ended the same way. Jupiter kept spinning, untouched, unimpressed. A world made mostly of hydrogen that simply refuses to burn. At this point, you might think we've run out of ideas. But we haven't, because there's one experiment so outrageous, it makes everything we've tried so far look reasonable. Far beyond Jupiter, another giant planet quietly orbits the Sun. Saturn, a world built from the same basic ingredients: hydrogen, helium, and unimaginable amounts of mass. So maybe, instead of trying to change Jupiter, we should change what crashes into it. Not an asteroid, not a comet, an entire planet. What if, instead of lighting Jupiter on fire, we threw Saturn straight into it? Because if anything could truly transform the largest planet in the solar system, it wouldn't be a tiny flame. It wouldn't even be a giant impact. It would be the collision of two worlds. At first, almost nothing seemed to happen. Jupiter and Saturn still looked calm. But gravity never stops working. As the two giant planets drifted closer, their invisible pull began reshaping the entire system around them. Moons slipped from their familiar orbits. Saturn's magnificent rings started to stretch, warp, and slowly tear apart. Every moment, the distance between the two worlds grew smaller. Closer, faster, closer, faster, until the largest planets in our solar system stood almost face to face. Then, for the very first time, the outer layers of their vast hydrogen atmospheres finally touched.